All right, so we're back. Mr. Chang is here with Mr. Chu, and I think we're doing a video of some examples, right?
Yeah. Definitely think that these transforming graphs can be pretty tricky, especially when there's more than one of those transformations happening at a time.
Okay, so I think we're only going to do it one example, right? The second example, which is the harder one, we'll save for another video. Okay, so
Oh,
here's
yeah, for sure.
the so-called easier one. All right, so we're starting out with f of x equals 2 times the square root of x plus 1 plus 3. And I think one of the things we're going to stress here is we're going to show individual transformations, right? But we have to start with the parent function.
Yeah,
Okay, so
yeah.
go ahead.
Yeah, so our parent function here, we can kind of think back to our library or a bunch of function families. I think this one's going to start off with the square root of x function.
Yeah,
So we can draw in, yeah, so square root of x, which we know looks like a sideways parabola opening up to the right in the top half.
Yeah, right. Okay, so let's
We were just
graph.
having a conversation earlier about how we're not sure how Zoom mirrors our cameras and stuff, so I'm not really sure, but I think this is correct.
All right, we could do like an XY table if we had no idea, right?
Right. Yeah.
Let's see. The Y would be the square root of X. Let me just do this. So if we had, let's pick easy numbers. So if X was 0, square root of X would be 0. If X was 1, 1. If X was 4, it'd be 2. Okay, so let's graph based on that. So we'll go with our parent function, which is Y equals square root of X. Okay, so let's graph that. So 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, 2. So it looks kind of like that, I think.
Well drawn. Looks pretty good.
All right, cool. So there's our parent function. Okay. It looks like there's several things we have to do, right?
Right. So we have that inside that square root, the argument of our function that is replaced with that x plus 1. So we know that that's going to slide or shift our graph to the left.
Okay, so you want, okay, yeah, I guess let's,
oh, sorry. And then there's also, we got vertical stretching with that times 2, and we have that vertical shift with that plus 3. The question is, when do I do which one?
Yeah, that's what I'm trying to think of right now. Does it really matter which one we do first?
So I think in terms of the shifting horizontally, since there's no horizontal compression or stretching, I think we can do that horizontal stretching right now.
Okay,
shifting.
So we'll do the horizontal first, right? So we want to go from, we're going to shift horizontal. So we're going to do this. So our next graph that we're going to do them one by one. So our first thing is we want to get to here, I think.
Yeah.
Right. So is that a shift to the left or to the right? I think it's a shift to the left.
I'm gonna have to agree with you, Mr. Chu.
Right.
And think of it as, the way I think of it is, in the previous video I said you're kind of tricking the function, quote unquote.
Yeah.
And so every point on the original graph has to have the same, like a corresponding point on the new one, right?
Yeah.
And so if the original graph, when I plugged in x equals 0, the output came out 0.
Yeah.
And so now the question is, what x would I have to plug in here to get the output of 0?
Yeah, that's exactly how I.
In a sense, quote unquote, tricking the function.
Yeah. So like
our function machine, yeah.
I think we're saying like, what number do you have to plug in here to make this whole thing 0?
Yeah.
Right, and that would be -1.
In this case, it's gonna be -1, right?
Yeah, so that's a shift to the left.
Right.
Right. Okay, so let's shift it to the left. Okay. What I always tell my students to do is like show enough detail to let me know what you're doing. Okay. So let's shift all these. We have 3 points, right? 3 reference points. So I'm going to shift them over by 1. Okay, by 1 unit. Okay, so there, and here, and we'll kind of draw it.
Yep.
Right. So let's just kind of describe what we did. So we moved from here to here. So that was shift or a horizontal shift to left by 1 unit. Okay.
That's good to me.
All right. So what would you like to do next?
So now the question is, do we scooch it up 3 units, or do we pull it up, or stretch it vertically 2 units or 2 times first?
This is, I think this is one is like a little, to use your terms, spicier than we had intended, because we could actually do this wrong.
So maybe we should, in this video, showcase both case or both, see what happens if you do it one way versus the other way.
Okay, so let's okay. So you want to stretch
now
it first?
push it up 3 units.
Okay, did you say stretch first?
Oh, sorry. I said shift it up.
Oh, shift it up. Okay, so let's shift it up.
Yeah.
All right, so we're gonna add 3. So we're gonna go to here. Y equals 2.
Wait, not the 2, just the square root.
Oh, shift it up 3. Yeah. Okay, shift it up. All right, so let's do that. Get rid of this. Okay, shift it up by 3. Okay, so we're adding 3, so that's gonna go up by 3. Okay, let's show where those 3 critical points are moving.
Critical points or reference points, yeah.
Reference points. Okay, so up by 3. So this point, 1, 2, 3, right up 3. So let's do it. 1, 2, 3. Everything goes up by 3, and I need to make room because I'm out of. Oh.
So while Mr. Chu is doing that, folks, I just want you to notice that when we're doing our shift, our graph, the actual shape of the graph, it's located in different spots, it's moving around. The actual shape is not different. It stays the same. When we're doing you're literally just grabbing it and then sliding it to the left, and then now in our case, sliding it straight up, but the shape still stays the same.
All right, so let's keep going. So what do we have to do next?
So our next part here is that vertical stretch now by a factor of 2. And so the way I would think of this is if I just multiplied all the y coordinates by 2, what happens now?
Right? Is that a question for me?
No, sorry. That's like the brain. That's what's happening in my brain.
Oh, okay. Sorry. So let's back up a sec. So what we're trying to get to is here, right? We're trying to let's not forget what we're trying to do. We're trying to get to this equation: 2 times x plus 1, or square root of x plus 1 plus 3. Okay, so now let's do this. Okay, so we're gonna multiply by 2, right? Here's the clincher. If we multiply by 2, we're multiplying the entire function by 2. Let me say that again, right?
Oh.
Right. This is where we can mess up. Okay, we have to take the previous function, which is this. We have to multiply that entire thing by 2. Okay, so let's multiply it by 2.
Right.
Okay, so here's why I said it's spicier than we thought it was, right? Because if we multiply by 2, the next function is going to be 2 square root of x plus 1 plus 6.
Right, because we'd be doubling that whole, using that one that you just circled as kind of the original function.
Yeah. So we got to be careful. So, I mean, we could do this, and then now we stretch everything, but that's not what we were trying to do. Right? So I think we need to back. I'm not even going to bother graphing this one at this point.
Right.
It's going to be not what we expected. It's going to be shifted up too far, right? We're trying to shift it up by 3 right here, but it's going to be shifted up by 6 actually. Okay, so I think what we should have done is we should have actually
done the stretching first.
Yeah, stretched it first, right? So let's do that. So let me back up. Let me erase. So let's kind of like Yeah, so this is where yeah, it gets a little bit tricky sometimes because we have to be careful of the order we're doing stuff. So let's go ahead and instead of shifting up, we're going to multiply by 2, right? So
Yeah, times 2.
okay, so we're doing a vertical stretch. Vertical stretch by 2. Okay, by 2. So let's go ahead and do that. So our next function, we're taking this function over here and multiplying that whole thing by 2.
Right.
So we have y equals 2 times that. Okay, so that's stretch, right?
Right. Yeah, just taking the same y values and then doubling them times 2.
Okay,
I think
so
that point on our x-intercept here, -1, 0, is still going to be -1, 0.
yeah, because if we multiply the output by 2, 0 times 2 is still 0, right? So
Right.
that goes there. The next point, we will multiply by 2. So 1 times 2 moves that up here.
Right.
And then 2 times 2 is 4. Okay, so this goes to 4,
Right.
I think. So 3, 1, 2, 3 over and up 4. So 1, 2, 3, 1, 2, 3, 4. So like that. Okay, so it's stretched. It's stretched. Oops, it's stretched vertically.
Yeah, it definitely looks like it has just been widened. If I think it has sideways parabola. Yeah.
Okay, yeah. Okay, and the last thing we need to do is take care of that 3. It looks like.
Right. So now we just got to lift it up 3 units on our graph.
Okay, so let's do that. So we're gonna vertical. This is a vertical shift by 3. Okay, so let's shift it up by 3. Okay, so I'll go, let's see, 1, 2, 3 right here. This point, shift it up by 3, 1, 2, 3. Then this point over here is just 1, 2, 3. So that's 5, I think.
Yep.
1, 2, 3, 4, 5. And this last one over here is 1, 2,
7.
3, 4, 7. Yeah, so 3, 7. 1, 2, 3, 4, 5, 6, 7 right there. Okay, so like that. And I think we've hit our target, right? So this is now y equals 2 times square root of x plus 1 plus 3.
Nice.
Yeah, so I'm actually glad we kind of like picked that example to show it actually matters.
Yeah, there is definitely a quote unquote order of operations or order of transformations.
Yeah.
To follow, folks. So definitely could get mixed up. But just if you think about kind of starting with your parent function and adding just one transformation at a time to get to your desired graph, in this case, 2 times the square root of x plus 1 plus 3. And just make sure you take your time and think you'll get there.
Yeah. All right, cool. I think we're done with this one, right?
Done with this one, I think.
All right, cool.